So tomorrow's quiz is the first quiz of the second quarter. It is going to cover that one day of information that we combined lessons 4.1 to 4.3. So all of the transformation information, and I'm going to show you that third slide from the notes. You need to memorize that third slide. And then it will also cover lesson 5.1 and 5.2. There are a total of 12 questions tomorrow. They are all multiple choice. There is no proof tomorrow. So from section 4.1 to 4.3, you need to memorize this slide. So you need to memorize the rules for the reflection and the rotation. The translation, I'll give you the rule. And remember, the translation was like the slide. Notice the SL in the word translation. This was the slide. And you're going to be given some type of rule, whether the rule shows you that it originally started as XY, and then they want you to take the X, maybe add 4 to all the X's, and then maybe subtract 1 from the Y's. Some type of rule that you will take each one of the X's and add or subtract something to it, and take each one of the Y's and add or subtract something to that to get your new order pairs. So that was the slide. And remember, you're sliding it horizontally or vertically. Then the reflection. You can either choose to memorize the rules here, or what's probably easier, so you don't have to memorize so much, is graph the original figure, graph the line of reflection, and then from there, you could just count the spaces away that the original is from the line of reflection, and then mirror it to the other side. Or memorize the rules. The reflection is like a flip. Notice the FL in the word. Over here, the rotation, I see 2 T's in the word, so this one is going to be like the turn. This one, you have to memorize the rules. It makes it so much easier. So memorize the rules for a 90, 180, and a 270 rotation. So this was the chapter 4 stuff. This is the third slide. The first slide was the title slide. The next one talked about the different motions, whether it was rigid or non-rigid. And then the third slide had these rules. So be able to go through these rules and recognize a transformation. Let me add a page here. And let me just tell you what to focus on from lesson 5.1. You need to know the triangle sum theorem. The triangle sum theorem just states that all 3 angles add up to be 180. We learned a corollary to that theorem. So the corollary to the triangle sum stated that the acute angles of a right triangle are complementary. Know how to apply these theorems and use them. We also in 5.1 learned the exterior angle theorem. And remember, that outside angle, that exterior angle, is equal to the sum of the 2 non-adjacent remote interior angles. Also in 5.1, we learned all the names for the triangles. So know the names based on their angle measures. And remember, that was acute, right, obtuse, and equiangular. And then we also classified them based on how long each of the sides were. And remember, that was scalene when they were all different, isosceles when 2 were the same, and then equilateral when all 3 were the same. So know the triangle names. Now, in the warm-up that we're about to do, in order to answer the first question, you needed to be able to graph them and then do the distance formula. You will not need to do the distance formula tomorrow, The way that I will ask the questions to classify the triangles is I will give you a picture with either numbers or congruency marks. So let's say I told you each one of these sides had a length of 5. What kind of triangle would this be? Equilateral. What if I gave you one with angle measures on the inside? What kind of triangle would this one be? Okay, based on the sides, because all 3 angles are different, all 3 sides will also be different. But what kind of angle name could I give this? Acute. So I will give you numbers on it. You're not going to have to do the distance formula, but know the 6 names or the 7 names for the triangles. From 5-2, all you need to know is how to apply a congruency statement and find the corresponding congruent parts, and then also know how to use the third angles theorem, which basically states that if you have 2 congruent angles in one triangle that are corresponding to another triangle, then the third one is also congruent. Or be able to use the triangle sum. If you have 2 of them, add them and subtract from 180. So that's basically your information for the quiz. Again, memorize the rules from chapter 4, and then that's the information from 5-1 and from 5-2. No proof tomorrow. So now let's go ahead and take a look at the review, and then we're going to go over the warm-up answers. Then in section 5.1, so the review that is posted, be able to do the translation, the slide, be able to take a rule and apply it to the order pairs. And you're just adding or subtracting to that X or Y. Also be able to look at a picture like this and tell me what happened to it. Did they reflect it? Did they translate it? Did they rotate it? What did they do to it? And what would be the rule? Then for the reflection, again, you either will memorize the rules or you will draw the line of reflection and graph the original and then reflect it across that line. And then for the rotation, you need to memorize the rules. Know how to rotate it 90, 180, 270. And then for 5-1, now this quiz review was initially set up for 5-1 to 5-3. However, the quiz is only on 5-1 and 5-2. So the questions that deal with section 3 get rid of. And it tells you this in the assignment. You do not need to do questions 6, 7, and 8. You can also skip 16C because there is no proof on the quiz. Now again, this quiz review does not cover everything. So this is why it's important that you go back through your homework, your notes, your warm-ups, and that's why we're about to do the warm-ups as well. All right, so again, you will need to be able to classify the triangles. However, I'm not going to give you 3 order pairs. Again, I will already give you a picture with either angle measures or side lengths on it. Now, in order to do this, you could either have chosen to graph it and then see if any of the sides were horizontal or vertical, and then you could have counted the spaces. If not, we would have needed to do the distance formula. So let me go ahead and graph this. I'm going to graph it on the next slide. So I'm going to calculate the distance of AB and AC. So I'm using the order pair 0, 6, -4, -1. I'm going to plug it into the distance formula. So -4 minus 0 squared plus -1 minus 6 squared. I get -4 squared plus -7 squared, which gives me 16 plus 49, which gives me the square root of 65. Now for AC, 0, 6, and then 4, -1, subtract the x's, square them, subtract the y's, square them, 4 squared plus -7 squared, 49 plus 16. Same thing. Notice these are equal, making the triangle isosceles because I have two sides that are equal, and when I graphed it, I saw that it was not a right triangle. The other way that you could have done it is calculated the slope to see if the slopes were opposite reciprocals. Then you would have seen that you had perpendicular lines, and you would have noticed that it was a right triangle. But again, tomorrow you will not have to do the distance formula. The triangle pictures will already have the numbers calculated. Now, be able to do a question like number 2 and find the value of x or even a missing angle. So for number 2, I'm going to use my triangle sum, and I'm going to add up these 3 angles and set them equal to 180. So I have 3x plus 20 plus the 2x plus the 50, and I set it equal to 180. I'm going to combine my like terms. So 2x plus 3x is 5x, and then 20 plus 50 is 70. Now that I've combined my like terms, I can begin my solving process. I'll subtract 70 from both sides. I get 110, divide by 5, and x equals 22. Now I'm going to take that value of x because it wants me to also classify it based on its angle measures. So if I take the 22 and I plug it in here, 2 times 22, that angle's 44. And then if I plug it in here, 3 times 22 plus 20, 66 plus 20, and that angle is 86. Now if I go back and look at all the numbers, 50, 44, 86, they're all 3 less than 90, making this an acute triangle. So I'm going to graph. This is number 1. So I'm going to graph these ordered pairs. So the first one is the ordered pair 0, 6. And then -4, -1. And then C is +4, -1. Once you connect it, you can already see that this is not going to be a right triangle. Now, to find the length of BC, since I've graphed it, I could just count the spaces, and I can see that BC here has a length of 8. Now, I could have also done the distance formula. Now, in order to figure out if AB and AC are equal, I need to do the distance formula. So let me go back on the other slide and calculate the distance. So for the exterior angle theorem, be able to recognize that these two remote interior non-adjacent angles are going to equal this exterior angle. This is an application of the exterior angle theorem. So I'm going to add 2x plus 40 and set it equal to x plus 72. I'm going to subtract x. X plus 40 equals 72. Subtract 40. X equals 32. But notice it didn't ask me to find x. It wants the measure of the exterior angle. So now I got to plug it in. So I'm going to do 32 plus 72, and that gives me 104 degrees. So be able to apply the exterior angle theorem. So in order to find x, I'm going to first focus on this triangle right here, because I got a whole bunch of triangles in this picture. And now in order to find x, I can use what I just did above in number 3. I'm going to use that exterior angle theorem. And I know that x, that exterior angle, is equal to adding the two non-adjacent remote interior angles. So all I have to do is x is equal to 32 plus 50. And that gives me 82 for angle x. Now, to find y, what I can do here, and again, I can do this different ways, but the way I'm going to do this one is I'm going to focus on this triangle right here. It's a right triangle. And I'm going to find the measure of this angle first. And I'm going to use that corollary because I know that these two acute angles are complementary. So I'm just going to do 90 minus 50. And this angle that's up here is 40 degrees. Now the triangle I can focus on is going to be this one right here. Because I already know x, it's 82. And I already know that other one is 40. So now I'm going to use my triangle sum, and I can do 40 plus 82 and get 122, and then subtract that from 180, and angle y is 58. So again, treat it like puzzles and then figure and fill things in. Different ways to do it. You could have found that you had a right angle here. You could have done 90 minus 32 and then got 58 for this one, which would have been vertical to y. And you could have found all these different angles. It doesn't really matter. There's lots of different ways to do these. You could have also done it as a quadrilateral and done 360. You could have realized that these were a linear pair and this was 98. A lot of different ways to do these. All right, so be able to do something like this where you're going to use the congruency statement. So, for example, the first letter A is going to match with the first letter there, which is D. And then the second letter, B, is going to match with E. And then C is going to match with F. So now what I'm going to do here is go through and fill in the stuff. So I can see that C is 40. So C was the last letter. It's going to match with F. So I can put a 40 here. And then E, which has a number, it's 80, is going to match with the middle letter B. So this one's 80. And now to find the measure of angle A, I'm going to use my triangle sum. I'm going to add 80 plus 40. I get 120. Subtract that from 180. And angle A is 60 degrees, which is also angle D. So angle A is congruent to angle D, which equals 80 degrees. And then now it wants us to match the side that matches with FD. So here, FD is the first and the last letter. So I'm going to match it with the first and the last letter here. So FD would match with AC, or you could say CA. I would accept either answer. And now they want me to take my original triangle congruency statement, ABC, congruent to DEF, and then now rearrange it. And they want me to match EDF. So remember, E matched with B. So that's what I put here first. And then D matched with A, so I put that second. And now I'm going to match the F with the C, and I put that there. So this is how I would rewrite the congruency statement for number 3. So we'll do the last example when we start to get ready for the test. Because there isn't a proof tomorrow, the proof will be on the test.